Start out with some rate law practice problems, section 12.3 still. And we're going to start with this problem here. If you remember how to do these problems, you can pause now. You don't need to watch the whole video. Do the problem yourself. Check it when you're done. Now I'm going to start, so go ahead and pause if you're going to pause. I need to find two experiments where the concentration is constant, and I see that right here, experiments 1 and 2. I note that the rate for experiment 2 is larger than the rate for experiment 1, so I will do rate 2 over rate 1, and that will be 4.8 times 10 to the minus 3. Now I'm going to substitute all the information for experiment 2 in right here. K, F2 is 0.1 molar, and ClO2 is 0.04 molar. I actually don't need to worry about the molar at this point because I'm just calculating the x and the y, the exponents. Don't forget to put in your x and y. And I'm going to divide that by trial 1. So the rate goes under the initial rate for trial 2. 1.2 times 10 to the minus 3. Now I substitute in the values for trial 1. F is 0.1 molar to the x. Chlorine dioxide is 0.01 molar to the y. Now I check what can I cancel. And I can cancel my k's. I also can cancel 0.1 to the x. It looks the same on both. So now I start my calculation. This piece right here is 4. 4 is equal to 4 to the y. And so y equals, yes, 1. Now I need to do another experiment. Find two experiments where the other chemical is constant in concentration. That would be experiments 1 and 3. Oops. So in experiments 1 and 3, the chlorine dioxide is constant and the fluorine is changing. And I see that the rate for experiment 3 is larger than the rate for experiment 1, so I will do rate 3 over rate 1. I will start with the third one. So I'm going to do rate 3 over rate 1. So rate 3 is right here. Rate 3, 4.8 times 10 to the minus 3, 0.2 to the x, 0.01 to the y, and I'm going to divide that by rate 1. Rate 1 is 1.2 times 10 to the minus 3, and I have 0.1 to the x, 0.01 to the y. Now I check what can I cancel, and I can always, oops, I just noticed I forgot to put in my k's, so I just put them in, but I'm going to cancel them because they cancel out. And the 0.01 to the y's also cancel out. My left side is equal to 4, and my right side is equal to 2 to the x. So what does x have to be? 2. 2 squared is 4. So now I know my rate. I know my orders and my rate. So the rate is K F2 to the x, which is squared, F2 squared, times my chlorine dioxide to the y, and y we found was 1. So right here I have my rate law. Remember, do not write rate law equals K, etc., etc. We write rate equals K, etc., etc. Okay, now there's another part to this problem. It said, find the specific rate constant, including the units. So I have to pick any experiment and just plug that experiment into the rate law. I am going to pick experiment 1. All experiments will give you the same exact values. So I'm just going to plug those values into the rate law, and that's this right here. Make sure you always include the units. So let's look back up here. The rate, we were given units for the rate and the concentrations. When I plug in the rate and the concentrations into the rate law to solve for K, I have to include units. So now let's solve this. I isolate K. K will be 1.2 times 10 to the minus 3, keeping my units, molars per second, divided by 0.01 molar squared. I multiplied out 0.1 molar quantity squared times 0.01 molar. And now I'm going to separate out my numbers and my units. With the numbers, I will end up with 12. You can do that on your calculator. But let's work out the units. Molar per second over molar cubed. Hopefully you can recognize that if we have molar squared and molar, we get the molar cubed. Up here, I just kept it the same. Now, what does that turn into? This is 12. Now, I have molar per second, and if I have something in the denominator, that's the same as taking the reciprocal of what's in the denominator. So molar per second times 1 over molar cubed, which is 12 times 1 over second molar squared, or 12 1 over molar squared seconds. Either of these is correct, and that is K. Okay, here is another problem. If you want to pause this, do it on your own, go ahead. I will show you this one, and the last one I'm going to just pause and not show you exactly how to do it. You'll just do it, and I'll show you the answers. For this one, I'll go through it, but pause now if you know how to do it. Okay, I got to find two reactions where two of the concentrations are constant now. And that would be reactions 1 and 3 work, trial 1 and trial 3, because the A is constant and the C is constant. Now I want to show you a little shortcut, and you're allowed to do this on the test, but you have to write out sentences. So I notice B went up by a factor of 3, because 0.05 times 3 is 0.15. And then I note that the rate also increased by a factor of 3. 1.1 times 3 is 3.3. Well, if the concentration goes up by a factor of 3 and the rate goes up by a factor of 3, then I know the order with respect to B is 1. So I know Y equals 1. You'd have to write out in sentences. For trials 1 and 3, A is constant, C is constant, B increases threefold, the rate increases threefold, therefore, the reaction is first order in B. Okay, and you can go through that kind of analysis with all of these. Let's do another quick one. I'm not going to write out the whole sentence. So we took care of B. Let's check for other ones where rates are constant. Let's see, reactions, trial 2 and 3. Trials 2 and 3, A is constant, B is constant. C increases by a factor of 2. And the rate, 3.3 times 2 is 6.6. We got 6.7, which is close enough to 6.6. So you would write a sentence in trials 2 and 3. A is constant, B is constant, C doubles, the rate doubles. Therefore, the reaction is first order in C. So first order in C. So now we've gotten the order for B and C. Is that right? We got B, we got C. We need to find A. So we need A to change and B and C to be constant. So let's find where B and C are constant. Oh, here we go. Trials 1 and 4. Trials 1 and 4. B is constant, C is constant. What happened to A? A doubled, because 0.05 times 2 is 0.1. The reaction rate, oh dear, went up by a factor of 4. So A doubled, the rate quadrupled. Do you see that that would be second order? Because A squared would be the ratio of the rates. So second order in A. All right, you'd have to write a sentence. In trials 1 and 4, B is constant, C is constant, A doubled, the rate quadrupled, therefore the reaction is second order in A. And you could get your rate law. But now we're going to work it out mathematically. So let's do the mathematics. Okay. I'm not going to videotape the whole problem solving. I'll just show you which which trials we need to look at. So we'll just do trials 1 and 4. And note in trial 1, the rate is faster. So rate 1 over rate 4, and I'm going to pause this and put everything in. Quick note here, so I've done rate 1 over rate 4. You come out with 3.93 equals 2 to the x. 3.93 is close enough to 4 to make the assumption that that rate ratio is actually 4. Okay, I'm going to now look for another rate 2 experiments to look at. Okay, so we're going to do trials 1 and 3, and I see between 1 and 3 the third has a larger rate, so I will do trial 3 over trial 1. I'm going to pause this and fill everything in. I get 3 is 3 to the y, therefore y must equal 1, because 3 raised to the first power is equal to 3. So now we have to find another 2 experiments to figure out the last exponent. And I see in trials 2 and 3, A is constant, C is constant, so I can get, oops, I'm sorry, C is not constant, B is constant. What am I thinking here? And I see that the rate for trial 2 is larger than the rate for trial 3. Therefore, I'm going to do rate 2 over rate 3, and I'm going to pause this and just fill it all in and work it out. Okay, when I do this math, I get 2.03 equals 2 to the z. 2.03 is close enough to 2. I'm going to call it 2. And 2 raised to the first power is 2, so z equals 1. I have my rate law. Rate equals k. What was x? Where's x? X was 2. Oh, another quick note. Note, right here we also made an approximation. That happens sometimes. So x is 2. I'm pretty sure y was 1. And z was 1. There's my rate, and now I have to solve for the specific rate constant. I didn't actually ask you to do that, but I'm going to add that in. Oh yeah, I did ask you to do it. Get the specific rate constant. And we're going to also include the units. So I'm going to work that out, plugging everything in, and just show you the work. I'm going to use the first trial for this. We could use any trial. You'll get the same value for k. Okay, I have plugged everything in from trial 1. I plugged everything into the rate law, and I isolated k. I want to show again, going through the actual math of this, because solving for the units is often really confusing for many students. The biggest mistakes people make are forgetting if you have a square, you have to apply it to the unit and to the number of what you are squaring. So first we'll calculate out our numbers. We get 880. I'm hoping I did that right. I checked it again, I got 880 again. Okay, let's look at our units now. We have molar per second in the numerator. In the denominator, I've got molar squared times molar times molar. So 1 over molar to the 4th, which is 880, 1 over molar cubed seconds. There's my K. All right, last problem right here. That'll be problem number 3. I'm going to pause this, just solve out the whole thing, give you the rate law and the rate constant. So go ahead and pause now. We're going to go all the way through, get the rate constant K and the units for K. I'm just going to have the solution up in a few moments, so pause now. Pause. Okay, so the solutions. I did rate 1 over rate 4. If you want to pause and check out how you solve for Y, you can pause it, but I'm going to keep moving forward. And then rate 3 over rate 4 lets you solve for X. You can pause this if you'd like. The little trick here is when you solve for X, X turns out to be 0. Because the only way for this to be true is if X is 0. And then I did rate 2 over rate 1 to solve for Z. Notice we get a number close to a whole number, and we can just assume that's like the whole number. I get my rate law. And again, just pause if you need to look at this. And then I solve for K. This says note here. So you can check your work. All right, that's it for this. That's it.